Hello, good evening all. Let's start with the session. So actually today we have in Guwahati a warning for this thing, weather warning for storms and all. So the internet is also, electricity is also going up and down. So if I go offline, just be patient with me. I will join in back again. Okay. So welcome you all to this live session. I'm audible, right?
Yes, sir.
Yeah. So welcome you all to this live session. This is the second session pertaining to numerical methods for engineers. So in the last session, I introduced you to myself. I'll just again briefly tell you for the newcomers. So I am the course TA for this numerical for engineers, and I would be taking the live session every week pertaining to the course that has been taught for that week. So we will do some sample problems that will be related to your assignments or the course syllabus in general for that particular week. If you have any doubts, you can talk to me directly here related to this course. So about myself, I am a PhD student at IIT Guwahati. I'm working on lithium-ion batteries, and I'm using numerical methods of ordinary differential equations and their solutions for my research purpose. So I use these techniques, so my knowledge would be helpful for you. I'm also learning with you all, so you guys can also discuss with me. Same here. Regarding the recording of these sessions, there is a one tab in your SWAM portal, a problem solving session, where you can go to the link in the spreadsheet. There would be a link and you can access to this. You can come here and see the recording of the sessions. The first recording is already uploaded for the previous week. So somebody you have missed, you can go back and see this session. Also, if you have missed the announcement in your SWAM portal, there is a discussion forum also where you can post your queries related to problems you're solving or the video uploaded. Anything you just get into while solving or something, you get into some issues or something, you can just directly put it. It's like threads we already previously had. So you can post your questions. One of the teaching assistants, so there are two more teaching assistants there, so they or me, I would be addressing. Sometime professor also, if he gets a time, he can also solve your query there. So these are the two about the logistics. So we'll start with the week 2 now. So in the last week we studied about, so this week we started with the linear system and equations, but previously for the computation and error analysis we were on the week 1 computation and analysis, what we did was, first we started with this Henon algorithm. Then we saw what is a relative error, what is absolute error, how they creep in. In last week we discussed elaborately about this. After doing that, relative errors, absolute errors, we saw what is a floating point representation for both binary and as well as decimal representation. Also after this we saw different techniques, that there are direct methods, there are iterative methods, and there are some sequential methods also. So usage of one of the techniques, it depends on what the problem is in your hand and what is the error analysis is due to the usage of. So relative errors, absolute error, there is a something I forgot one thing here, is that truncation error and round off errors were also discussed, right? So what is how this truncation error come about, how round off error comes in about, we discussed briefly previously in the previous week, and how they propagate and what is the nature, how analytical even if the expression is analytically similar, how they are numerically not similar, and how you have to be cautious, that we saw in the last week. Now this if you have still any doubts, you can go to the video lecture that is uploaded, video recording in the previous session and get back to me. even for this class, we'll start with the linear algebra basics. So linear algebra basic in the week 2, we started with the what are matrices. Previously vector, what is a vector representation, what is a matrices, what are the properties of the matrices. So this was your +2. What are the commutative laws, associative law, product of the matrices, how we do it, we saw it there. Then here linear equations and the visualization. So any linear equation, let's say 2x1 plus 5x2 is equal to 0, can be represented on the 2D plot as if you put x is equal to 0 here, x2 is equal to 0 here, x1 would be -2, x1 would be -2. So similar, so you can plot the equation, so put the x2 is equal to 0, so x1 would be 2x1 would be 0, sorry, so x1, what am I missing here? Yeah, so you can get down to the equation form here. Then what is the rank of the conditions and the solution and the linear equations we saw. So if you have a augmented B matrix, and then if how the rank comes about in the equation, what are the linear equations are about. So what is the rank is, if you have a system of linear equations, so let's say A1 2x1 plus 5x2 is equal to 8. So if you put 8 is equal to something, then you will get some equation line, okay, because the 0 is there, it is passing through origin. So that's the thing. So 2x1 plus 5x2, you are getting the point here, right? If I put 8 here, then there would be x1 would be 4, 2x1 is equal to 8, so x1 would be 4. So that point would be 0, 4 here, 0, 4, and then if I put x2 is equal to 0, sorry, this is, yeah, this is 4, 0, and put x1 is equal to 0, so x1 is 0, and x2 would be 8 by 5 something. So that is the line. So 2x1 plus 5x2, because I actually got the 0 already, so that was passing through origin. So if you have this kind of a form, so this 2x1 5x2, or there is some other equation, let's say 4x1 plus 7x2 is equal to 9. So you can write this as A augmented B matrix. So A augmented B matrix would be 2, 5, 4, 7, 8, 9, right? So this A augmented B matrix you will get. This A augmented B matrix, if you reduced it to the row echelon form, you will have a non-zero rows and 0 rows. If the non-zero rows are, so number of non-zero rows will give you rank of the matrix, right? If the rank of A is equal to rank of B, A augmented B, then we have a unique solution in the case where it is equal to n. So what is n? In this sample problem I have taken, there are 2 variables, right? So there are 2 unknowns. So for 2 unknowns, the n is equal to 2. If the rank is equal to number of unknowns, then in both case, then in that case it will be having a unique solution. Then if the rank of A is not equal to rank of B, A augmented B, sorry, in that case you will have a no solution. And in the rank of A is equal to rank of B, but it is less than n, the number of unknowns. So instead of 2 it would have been a 1 case. In that case it is having infinitely many solutions. So if just for the completion sake, unique solutions means if there are 2 lines, they are intersecting at some point. No solutions mean there are 2 lines which are not intersecting or something, and which are not intersecting, and rank of infinitely in the case of infinitely many solutions is that the two lines are overlapping with each other. So they are exactly overlapping with each other, two lines. So that is for the case of what we say, two unknowns or a 2D space line equations. You can extend it to the 3D space also. I would give you the task, you just Google it, you will get the idea of how it is about the plane. So any plane can be represented by the line of like 7x1 plus 8x2 plus 5x3 is equal to some value 7. You will get some plane. So you can just Google how this, so this can be extended in just, this can be extended for the three-dimensional space also, 3D space. So I'm having a less space here, I'll just yeah, maybe, yeah, okay. So 3D space would be, let's say 8x2 plus 9x3 plus 5x. So we'll see the problems, then you will get the understanding. So problems are the good way to understand the problem. So let's just finish this off and let's move it to the problems directly. So in the Gauss elimination methods, Gauss-Jordan method, LU decomposition method we saw. So in a Gauss elimination, we just saw naive Gauss elimination. So at the end, if you have you guys completed the video lectures? Both of you there, right? For this week?
Around 80% I see.
Yeah, so
at the last 1 is left.
Okay, and there is some other lady, I guess, or someone, Maria, yeah. So if you have seen the video lectures completely, at the end of the video, professor talks about why it is this elimination method fails at the some stages. So there is something called a modified elimination, Gauss elimination method also, that we'll see in the next class. So we'll take some problems of these equation, Gauss-Jordan method with LU decomposition, and then you will get an understanding of what I'm talking about. So let's get started with the problems. So the first problem was like find the solution of the linear system for this linear system by Cramer's rule. So by Cramer's rule, please report the values of x1 and values of x2. So you have values of x2, yeah, only x2 and x3. Okay, you have to tell the values of all three. So can anybody tell me how to go about this one?
You have to reduce it to 0 1 by 1.
No, they have said explicitly it should be by Cramer's rule, right? Before going to that, first you have given the system of equations, right? So these are three equations here. So and three equations have how many unknowns? 1, 2, and 3. x1, x2, x3. So it is not a line representation; it's a plane. So visualization part you can do it yourself. You just Google it, you will get it. We'll do how to solve this, how to get the solution of this. Okay. So first you have to, yeah, Maria is correct. We have to first find a delta, determinant, determinant of the matrix. Which one? So we have to first find, so first you write down the equation. System would be written as T23 minus 1, 1 minus 2, 1, 1 minus 12, 5. Right? By Cramer's rules mean first you have to find D. D is nothing but the determinant of whole 2, 3 minus 1, 1 minus 2, 1, 1, 12, 5. Right? It's pretty straightforward. 2 into 5 into 500 minus 10, minus 10, minus 10 minus 12. Minus 10 plus 12 is 10. then into 3 minus 1 into. So 5 minus 1 4 minus 12 plus 2 is minus 10, right? So what will be D? D would be 2. So your x1 would be d1 divided by 2, that is d1 divided by d. X2 would be d2 divided by d, that is 2. X3 would be d3 divided by d, that is 2. This value is d, okay, for all. So what is d1? Yeah, so what is d1? In d1 we have to take the this minus 2. So d1 would be, you have to cancel these two and take the determinant of the remaining ones. Minus 2 1 minus 12 5. D2 would be yeah, in here you have to cancel these two. First we took this one and cancelled it. Second, in D2 you are taking pivoting this point, and that point you are cancelling out. So your determinant would be 1 1 1 5 1 1 1 5. D3. In D3 what we'll do, we'll take this one, we'll cancel this. So 1 minus 2 1 by 12. 1 minus 2 1 12. Oh, sorry, I'm going down here. So pardon me for this. Two 3 minus 1. This is 1 minus 2 1 1 12 5. So we have a b value, right? So what is a b value? B side 4 6 10, right? So what we have to do, I actually got confused with this 2 by 2 and then solving it. So your d1 would be again a 3, it would be a 3 by 3 matrix. So what you will do now, d1 would be at the first point, right? So you will hide this first point, first column. We'll hide this first column. Instead of that, you will put this column here, and so take the determinant of it. So 5 6 4 6 10 3 minus 2 minus 12 minus 1 1 5. So take the determinant of it. So 4 into 2 minus 3 into 20 plus minus 1 into minus 52 divided by. So you're getting now how I am getting this 2 3 and minus 2. So the similar approach what we did here. Here we got 2, right? So what would be d1? D1 value Are you guys following with me?
Yes, yes.
Yeah, so you got this 4 into 2 minus 3 into 20 into this one, right? So it's basically would come out to be minus 52 plus minus 52. It would be 0, I guess. Okay. Similarly for now for second one, what we have to do, how d2 we will calculate. Now you will hide this point. We are working on this point, right? So instead of this column you will put this column. D3 similar, you will keep these two similar and you will put the B here. So what will be your determinant matrix? Determinant will be, you will take 2 1 1 4 6 10 minus 1 1 5. It would be 2 into
20.
2 into 20, right? 6 15 20 minus 4 into 5 minus 1 4 plus minus 1 into 10 minus 6 4. How much it would be? D2 75. Please check your calculations. I guess it will not come 25. It will come out to be 40, I guess.
Sir. D2.
Yeah?
D2 20.
40 minus 6. Yeah, it would be 20. Yes. It would be 20. Yeah, it's D3 similarly you will put 2 1 1 3 minus 2 12 3 minus 2 12 and 4 6 10. So 2 into this is 10. Okay, 10 20 minus 20 minus minus 20. Yes, how much is it? Yeah, it's 20. So this is 20 minus minus 20 minus 72 plus 72 minus 3 into 10 minus 6 4 plus 4 into 12 plus minus 12 plus 2 minus 10. D3 would be, this is 52, so this is 52 into 2. 52 into 2 minus 12 minus 40. So this would come out to be 52, right?
Yes.
So what would be value of, say they want to calculate x1. X1 is d1 by 2.
So once again, I have to check determinant, the 2, answer of determinant.
This d value you asking.
Who you got, that is I have doubt, maybe something wrong.
No, no.
Once again, I have to cross check.
You try it again, it's correct.
No sir, I tried sir, it is correct.
Yeah, it's 2. Yeah, 2. It would be 2. Yeah. So d1 0 divided by 2 is 0. X2 would be d2 divided by 2. 20 divided by 2 would be 10. And x3 would be 52 divided by 2, that is 26. So this is how you get the value of. correct? So any doubts in this? You're clear with it, right? How you will solve with Cramer's rule, the 3 by 3 matrix. So what is a 3 by 3 system? It is actually a 3D space. So x, y, z. So you can just see how the row echelon, rank and how, what is the intersection of this line of this of this plane's mean. So you just Google it, you will get it. So since it is readily available on Google, I am not again going in here. So them these are just solving the problems which are not solved in any books or something. So question 2 is, consider the following set of linear equation. So they are given you the two equations here. For the value of this epsilon equal to 0, express the above set of equation in the form of ax is equal to b. Also solve the set of equation with epsilon is equal to 0 and report the value of x and y. So basically what is asking you, put value of epsilon equal to 0 and tell me what is a augmented b would be. That is nothing but axb. And now solve the above set of equations for point 1. So in the b, what is saying, instead of 0 put it is equal to 0.1 and check if there is a change in the solution, and if there are this change the solution, report the reason for it, why it is changing. Yeah, so in the first problem it is asking you to put it as a 0, and get a augmented b, solve for it, get the value of x and y. In second it is telling you put it as a 0.1 and get the value of x and y and compare. So first let's start with it. So what would be a augmented b, or ax is equal to b is nothing but it's similar thing. A augmented v would be 0.99, 1.01, coefficients of x and y, then coefficient again x and y, 1 minus 1, then here it is 1, and in the first part we have to put it as a 0, so that would be this thing. Is it correct?
Okay, right.
So you have to solve it, right? How you will solve? How to solve this? I guess 80% somebody said, right?
Gauss elimination.
Yeah, Gauss elimination we have to perform. R2 we will change it to
0.9.
R2 plus negative of 1 divided by 0.99 R1, right? So this row would be similar, this will become 0, we know that. So here what is it, minus 1 plus minus 1 divided by 0.99 into 1.01. Here value would come here, it would be 0.02.
Summation.
Right? Then here 1 plus minus 1.09 into 1. So what value will come here? Minus 0.01. Okay. So you got the you have so what will from here you can calculate value of y. So 0.02 y would be is equal to 0.01. Implies y is equal to
0.01 by 0.02.
0.5. It's a half of 2, right?
Yes, minus 0.5.
Now you put this value here and then you'll get the value of x. So
Reverse substitution.
back substitution, yeah. X minus 1.01 into 0.5 is equal to 1. This I got from here. So what will be x? 1 plus 1.01 into minus 0.5 divided by 0.99 implies x would be 0.5. Is it correct? Is it correct?
Yes.
Right? So you are satisfied with these values, right? We got the x and y value and it's correct. Now let's solve for the second condition. So this is for A. So in B, right? Epsilon is equal to, so this is epsilon is equal to 0, epsilon is equal to 0.1. So what will be your A augmented B? The rest of the things would be same. This value only will change, right? 0.99 minus 1.01, 1 minus 1. Instead of 1, it would be 1 plus 0.1. 1 plus 0.1, it would be 1.1. Again same, R2 is equal to R2 plus 1 divided by 0.99 R1. This is the same, right? This will become 0. Now you have to calculate this. Again this will be same one, right? Because the value is same. This will be again 0.02. Here R2 is 1.1 plus minus 0.99 into this one, R1 is 1. So what is the value here? Could come out to be 0.089 or 899.
0.089?
Yeah.
8989.
Yeah, 8989 continuous. Yes. Right? So let's find out the value of x and y. So y would be 0.089 divided by 0.02. What is 0.890 by 0.02?
4.4949.
4.545 you can just say, right? xy is equal to, x would be 1 plus 1.01 into 4.45 divided by 0.99.
5.595.
5.55 you can say. So this is your x. Can you see the difference? What were your x and y? X and y. And the change in the value is just a fraction 1, 0.01. Not even, we didn't even add integer to this. From 1 we just went to the 1.1 to the B side. So there's a solution change. Can anybody tell me why?
Rank of the matrix.
Rank of the A and B was same, na? This is rank of A augmented B is 3. Rank of A is also 3. Rank doesn't tell you about this thing. Rank only tells you if there are solutions, how many solutions would be there, or if there is a solution. The thing is, the system itself is ill conditioned. So there the numbers are very nearby, right? So the system, so if you plot it, it would be very close by. So so it is very close by lines, right? So if you zoom in, when you change so when they intersect, would the change in that situation. So that is why that is called as a ill conditioned system. So it is a classic case of ill conditioned system.
Okay.
You're getting it, right? So we'll go forward. Question 3.
Okay.
For the following system of equations, comment the nature of the solution. So when they ask you nature of solution, that means you have to find a rank. Okay. Only rank can tell you about the nature of solution. Rank will never tell you about how if the system is conditioned or ill conditioned. It will just tell you, given the system, is there any solution available to the system or not. That's it. So if you want to find it out, you have to do this thing. You have to do the eigenvalue calculation. So it is very involving solution. That's why I didn't take, because they have to take different problems of different these things. But you can calculate eigenvalue, and if the eigenvalue is very small, in that case it is ill conditioned. So for a question 3, we have this system and they're asking you what is the nature of the solution would be, right? So let's just find out. A augmented B would be, A augmented B would be 2, 2, 1, 5, 1, minus 1, 1, 1, 3, 1, 2, 4. Right?
Okay.
You can directly go for a row this thing, but Gauss elimination directly go. But we will so writing ax1 plus bx2 is equal to c, and lx1 plus mx2 is equal to n. In that case, you can write this first and you can write this second, right? It doesn't make any sense. If there are just two lines only, how you represent it doesn't matter. So what we'll do, for easiness sake, we will swap this row. Okay, so row 1 to row 2, so that we will always have a 1 at a denominator in the is this thing while doing Gauss elimination. 2, 2, 1, 5, because already there is a 1 already present in this thing, right? So we can always do. Don't, if there is no 1 and they have asked you with the Gauss elimination, don't divide it. Then you are doing some modifications to it. Don't divide. That will give you the correct answer. That is not the case, but in the exam I'm saying. So if you are talking about the exam case, after this, if anybody wants to do the certificate of this, they can take the what we say is they can do it by giving the exam, right? So in exam they might just ask you for a Gauss elimination only. In that case, you can do the swapping, but don't do this division. If the division multiplication is done, then it will go into the modified Gauss elimination that we will see in the next module. Next week. Okay. So only swapping is fine, but doesn't change the meaning. So R1, R2 we swapped. Now R2 would be Gauss elimination routine R2 plus 2 divided by 1 R1. R3 would be R3 plus minus 3 divided by 1 1. Okay. R1. So what you will get? 1 2 1 5. This will be 0. This will be 4. This will be minus 1. This will be 3. Again 4 minus 1. This will be 1. Right? So 2 plus 2, 1 minus 2, 5 minus 3. Next step would be, are you getting this right?
Okay, same Gauss elimination.
Yeah, same Gauss elimination. If you did, R3 would be R3 plus minus 4 divided by 4. So it basically is minus 1. 4 divided by 4 R. Using this, you have to do this. So 1 2 1 5 0 4 minus 1 3 0 0 0, but this will not become 0. 1, so that is 1 minus 1 into R2 is 3. So 1 minus 3 is equal to minus 2. Right? So what is the rank of A? What is the rank of B? Rank of A, how to find the rank of A? So rank of A is nothing but the rank would be number of non-zero rows. So how many number of non-zero rows here?
1.
Completely non-zero, I mean completely. That is 2, right? This one and this one. So this is 2, and in this case this is right.
Okay.
So what would be the nature of solution? I briefly told you in the class also. So I'll just revise again.
Not equal to 0 is finite solution.
But finite solution. So I'll just go again. Rank of A is equal to rank of B, and is equal to number of unknowns. It is n. In that case only you have a unique solution. Okay. A rank of A is equal to rank of B, but it is some value m is less than n. In that case, you have infinitely many solutions. Okay, and if you have a rank of A not equal to rank of B, in that case you have no solution. So here rank of A is not equal to rank of B. So there would be no solutions. If this value would have been 0, in that case what would have happened?
M is equal to M is the number of rows or columns, sir?
M is again number of rows only.
M.
We are just representing what is would
M
be the
cross
rank.
N. M cross N matrix like that.
N cross.
M cross.
No, not M cross N. I'm just denoting what would be the rank. So this rank of A, rank of B, right? I'm just denoting rank of A as a M, and N is your number of unknowns, that is constant. So in this case, number of unknowns are X, Y, Z, that is 3. Okay. So number of unknowns are 3, right? But rank of A and rank of B is decided by the number of completely non-zero rows. So completely non-zeros in this case, for only A was 2, for B there are 3 for the previous case. Now I have removed it to the 0, all are 0, okay. So rank of A would be, in this case would be 2, right?
M 2 and rank of B is also 2.
2. So this is, I am calling it as a M, which is less than N. So it will have a infinitely many solutions. So because here you got a -2, right? Here, because here it was a -2, you got this. This will have a no solution. Right? Okay, so we'll move ahead. We'll go question number 4.
Its meaning is changing. M cross N. It is not number of rows, number of columns.
Yeah, you can change. You can, so you can, let's say this is for your sake, you can say it Q also. Whatever.
Actually, because same notation is confusing. Usually, what we'll say, always in our mind, so you are using same notation.
Yeah, that's true, but it is M that I should have been telling you. M is nothing but the number of the rank only. I'm just saying
N is number of
denoting as a M
unknowns.
here. Yeah.
According to this case.
Yeah. So it's understood, right?
Yes.
Maria, you are okay now?
Yes.
Yeah. So question 4, we'll go ahead. So here they are asking you to solve the system equation again with the Gauss elimination and the Gauss-Jordan method. So we'll just do this. What would be your A augmented B? Now it is routine to you. A augmented B is 1 minus 1 minus 3, 6 2 2 2 minus 3 4 1 1, right? So in Gauss elimination, what we do, you know, right? You have to just make these values 0 using the what we say,
Lower triangulation.
yeah. So R2 would be R2 plus, how I am writing this, you getting, right? This is 6 divided by 6 divided by 1.
In the place of just mentioning R2 dash like that, that is, it indicates the new row.
Sorry?
In Gauss elimination, R2 is there, you are using new rows. Next steps, you are using new rows, that is R2 dash or R2 cap.
It's not
notation.
necessary. If you want to do it for your own sake, then it's fine. But it just be changing the row to some other this one, and that one is not going to end essentially going to go for a solution. What you remain with it. So how many things you will do? R2 R2 dash with R2 double dash. It will doesn't make any sense, right?
That means
You can
at
just
least
put this and go ahead with it. So this is what we do in also solution also. So sorry, in the while doing if you guys are interested in doing MATLAB or
it
Python,
is
right?
same problem, same notation at different steps.
So it is just saying R2 is
In the place,
R2 will be R2, the R2 it is there plus this thing. So this is R1 here.
next
So
steps, it's a new notation. It's somewhat, we feel it, it is new row.
okay, fine. If that's the case, then you can go ahead with it. No problem with that. If it is also fine. If you want to change the notation, but essentially it is going to change at that row itself only in the next iteration. It's not an iteration. It is just direct method only. So 1 minus 1 minus 3. This one would be 0. 2 minus 6 minus 4. 2 plus 6 8. 2 plus 18 20. This would be 0. 4 minus 6 would be 4 minus 6 minus 2. 1 plus 6 7. 1 plus 18, this would be 19, right? Sorry, what I'm doing. For R3 I didn't write only while talking. I forgot to write R3. So for R3 would be different, right? R3 plus this thing minus 3 divided by 1. I have to take negative of this again. So this will be plus 3 R1. So this is basically a 3 only. So this will be 0. 4 plus 3, this would be 7. 1 minus 3, this will be minus 2. 1 minus 9 would be minus 8.
Okay.
Right? Now R3, again you have to make 0 here. So you have to make 0. R3 would be R3 plus this one divided by this one, negative of it. 7 divided by minus 4, negative of it. So it basically 7 by 4 only. Okay, plus R2. So what you will get? 1 minus 1 minus 3.
So in the place of multiply by R2, you can multiply with R1. Not possible. Huh?
If you multiply with R1, what will happen? This 0 will again go in
Some value.
yeah. That is why the process is like that. You have to go into the upper triangular matrix, right? So this equation will be similar. Here the 0, this will be 0. How much this would be? Minus 2 plus 7 by 4 into R2, that is 8. This is 2, 7, 12 minus 2, right? 14 minus 2. This is 14 minus 2. This is 12. Similarly, minus 8 plus 7 by 4 into 20. This is 5. Right?
Okay.
Now you have reduced it to the upper triangular matrix, right? Now you can do back substitution. So 12 it is represent x1 next to x3, right?
x1 next to x3.
So x3 would be 27. Implies x3 would be
27 better.
2.25. Right?
Yes.
x2 would be 20 minus 8 into 2.25 divided by minus 4.
Minus 0.5.
Minus 0.5. x1 would be minus 3 minus 1 divided into x2 and plus 1 into x3. So x2 and x3 you know.
Okay, so getting signal.
Yeah. My slides are visible,
Yes.
right?
Hmm. You have to find out x1, sir. Still incomplete is showing.
Yeah. x1, are you able to see my slides?
Now you got, sir, the x1. Start to steering. Getting
x1 value would be
minus 1.
minus 0.25.
Okay.
Now second he is asking you to solve using, so you got x1, x2, x3. The second he is telling you to solve using Gauss-Jordan method. A augmented b, what is A augmented b? 1 1 minus 1. This A augmented b at the start would be similar, right? 3 6 2 2 2 minus 3 4 minus 3 4 1 1. So here upper triangle, so in the case of Gauss elimination, we were not concerned with the what are the elements are there at the
Upper triangle.
at the upper side. This at the diagonal also we were not concerned about, but we were just concerned that we have to get 0 here. That's what we were doing in Gauss elimination, right? In Gauss-Jordan, what we will do is this is your diagonal elements, right?
Hmm.
We will try to get 0 here and 0 here also.
Hmm.
Okay.
Okay.
So we have to get 0 here and 0 here, so that once you get the final form, you just have to you will not do back substitution. You will directly get the values of x1, x2, x3, or whatever the variables there are in. So let's see how to do that. Okay, this is -3. So the first one would be similar, R2. There is nothing above this, right? Only below this. So only below that we will change. So this 2 we will so there is nothing below this, the first one. Only 6 and only -3 is there, right? So we will, for that only downside, we will change this thing. So R2 would be again R2 plus -3 divided by 6, a negative of it. Sorry, 6 divided by 1, negative of it. R1. R3 would be R3 plus same thing, -3 divided by 1. R1. Sir, if you don't mind, while solving, you can mute it. If you want to speak something, you can unmute this thing. Yeah, thanks, no problem. Yeah. So what would be A augmented B? This first step will be same as a Gauss this thing method. So it would be 0, 4, 0 minus 4, 8, 20. 0, 7, minus 2, minus 8. 0, 7, minus 2, minus 8. Till then you are fine, right?
Okay.
What is the second step? Next one.
Again, make it to 7, 0. First, have to target lower diagonal. Next, have to target upper diagonal.
What do you do here first? What can you directly go for this, or there has to we have to do something else? So what we'll do is,
Sir, R1 can multiply by 2 and subtract from R3, sir.
R1?
R1 is multiplied by 2.
R1 multiply by 2 and
Subtract from R3, sir.
why would you do that? To get 0 here.
No, sir. In place of -1.
Here. So to get a 0 here, you have to divide it by 2 and then minus it from here, right? So first what?
R1 is multiplied by 2.
So R1 multiplied by 2, you are saying. R1 multiplied by 2.
Yes,
okay.
sir.
So R1 multiplied by 2, and what you will do? You will reduce it, subtract it from, add it in the what? Which one? R3, right? You're saying
Subtracting
from
yes, sir.
R3. But
yes, sir.
then you will change R3. No, R3 has to be done for R3. So the syntax goes like R3. What you're changing for R3, then R3, sorry, minus R1 into 2. That's what you're saying. But you just
Yes,
can't do
sir.
it directly like that, right? You have to follow some procedure. And by doing this, you will get 0 here. But you have to get 0. So that's what we are saying. We have to do 0 here also in Gauss-Jordan.
Okay, sir.
So we'll have to get first 0 here and 0 here. In the last step, what we would have done, we would in the this is also not correct for a Gauss-Jordan Gauss elimination method also. Okay, Maria. This
Okay.
first
Okay, sir.
we have to do first 0 here and then go with the that is the thing. So which is the corner element below that you will do the 0 for a Gauss elimination. In a Gauss-Jordan, you will see what is the corner element, and for the corner element, you will do both this thing and this thing 0. You can only corner element are allowed to use for this thing, multiplication, this thing. So why we are using corner element? Because we have to get this 0 0 0 0 form. If you change, say this, you will not change here, right? So and then the problem would happen with, if you change this thing, okay, in the next one, if you change something, your first value would also change because of some manipulation. So that is why always use the corner element.
Okay, sir.
So what we can do is, we can divide this by 4 first, right? So we will divide this by 4, R2. So we are talking Gauss-Jordan, no? R2 divided by 4. So what we will get? 1 1 minus 1 3 0. R2 divided by minus 4 will do. This 1 minus 2 minus 10.
So minus 5,
Minus 5.
20 divided by 4.
Yeah. Here 0, 7 divided by 4. This is minus 2 or what? This is 1 plus 3. Yeah. So minus 2. So that will become 12.
So only changing R2 row or even R3 also?
Oh, I went ahead. Okay, sorry. Here we are just changing this thing. Tomorrow 7 minus 2 minus 8. Okay.
That's why the different symbol if you used is easy to tackle.
Yeah, that's
Same
true.
symbol again, lot of confusion.
No, this R2, we are just changing R2 here. So I thought I did it the R3 also. So that's it. For R2 we are changing. Now what we'll do, using this thing, using this thing, this row, using this row, this column, we'll make a 0 here and we'll make a 0 here. How do you do this? Simply straightforward, right? So using this here, so for R1 we are changing using R2. So R1 would be R1 plus this divided by this. So 1 divided by 1 minus R2. R3 would be R3 plus this thing. How the bracket is 7 divided by 1 minus R2. So 1 1 minus 1 3 0 1 minus 2, sorry, here we are changing, right? So 1 will not change because this thing will not change because 0 is here. Then 1 would change to be 0, right? This is basically minus 1 only. So minus 2 plus 1,
minus 1.
would be there. Sure. Have you done any mistake somewhere?
Minus 1, minus 1, minus
1, minus 1.
minus 2.
Minus 1 would be there, right?
Yes, sir.
Okay. 3 minus 5. 3 plus 5, right? There was something a mistake.
Plus minus 1.
We are subtracting R1 minus R2 or R2 minus R1,
This
sir.
R3, this thing we didn't take correctly, right? 1 1 minus 1 3. This is 1 1 minus 1 3. 6 2 2 2. Correct? Minus 3 4 1 1. Okay. Then we got this form. Then we divided by minus 4. Here it should be minus 3. R1 minus R2 or R2 minus R1. See, guess it is getting confusing for you guys. This is R1, this is R2, this is R3. In Gauss, whatever this thing will always do, use the pivot element. The corner element. The corner element would be at this. This would be corner element. For this one, we are using this. Right now, we are using this one. So this is using this. We are changing which one? R1. So we will write R1 first. Okay. R1 is changing to R1 plus what? 1 divided by 1, negative of it, R1, R2. So using R2, you are changing R1. So it will basically means R1 minus R2. Okay. R3 would be, R3 will change from 7 divided by 1 negative using R2. So it would be R3 minus 7 R2. So both we are changing using R2 only. Maria, does this solve your this thing?
Yes, sir.
Yeah. So this way you have to do. So I'll just tell you the solution so that, because we have 2-3 questions also. So here you will get 1 0 1 2 0 1 minus 2 5 0 0 12 27. Now what we have to do, we'll first get 1 here. So here you will write R3 divided by 12. Okay, R3 will be R3 divided by 12. So you will get what? This will boil down to 1 0 1 2 0 1 minus 2 5 0 0 1. 27 divided by 12 is 2.25, right? Now again the same thing. Now Maria, what we have to do now? We have to use this thing, sir. We have to use this thing. Using this, we have to make this 0, right? So you have to make this 0. What we will do? R1 I will change R1 plus
multiplied by
2. Yeah, addition of 2 only. 2 divided by 1. It is already negative, so it's this thing. No. Multiply by 2 only, right?
Yes, because already negative is there, it is positive.
Yeah. No. I confused you guys. We are using this one right now. Using this, we'll have to make this 0 and this 0. So R2 would be, R1 would be R1 plus minus 1 divided by 1. You always have to use the diagonal element, that's it. We already were done with these two, so right now we are at this juncture. So for this one is the diagonal element. Using this one, we are going to do this 0, so that it will be 1 0 0 0 1 0 0 0 1.
Mm-hmm. Okay, lower triangle is already 0.
So this would be R1 R3. For R2 plus minus of this thing, 2 divided by 1, and this will be 1 because this is already negative. So basically you have to create a 0 here. How you will create a 0 here? That you have to think. You can create 0 here by multiplying this by 2, right? And adding into it. So that's what we are doing. R2 can directly write this step. I am writing this way because professor has told this way. But you can, if you go ahead, you can directly write, okay, we have to make this 0. I have this 1. From 1 I have to make this thing 0. So I have to multiply this 1 by 2 and add this. So that's what I am writing here. So that basically means the same. So you will get it as 1 0 0. Here you will get 0 and 2. This 2 will change to minus 0.25. In 0 1 0 0 0 1. Here you will get 0.5. Here 2.25. The same, right? Here 0 minus 0. Maybe you can work again while the meantime and then get back, because we already all have more 2 questions, I guess. Yeah.
So you have not calculated the variables x1, x2, x3. Means
So
x1 is
now x1, x2, and 3 would be what? So directly, because this one would be what? x1 plus 0 would be minus 2.
x1 is 0 plus minus 0.25, x2 is 0.5.
So directly you will get the value of
x3
x1
is 2.25. Okay.
Second, LU decomposition. So what is LU decomposition? Anybody remember? So A can be written as L into U. This is a lower triangular matrix and upper triangular matrix. So lower triangular matrix would be your values of what? First upper triangular, you tell me. What is the upper triangular matrix? This is matrix you get after Gauss elimination. Matrix after completion of Gauss elimination. So that is this one. For A it is talking. So what is A? A is nothing but these three, right? We started with this A augmented B. So this is A. So at the end what A you have? This A you have. Right? So that is your U. 1, 1, minus 1, 0, minus 4, 8, 0, 0, 12. That's what you have got. Okay. And lower triangular matrix is, so this is upper triangular, lower triangular matrix is, your this all would be 0. These three places would be in Gauss elimination. You have done this, these values, this value, this value. This will be alpha 21, this will be alpha 31, this will be alpha 3, 3. So the order is important here. First we have to use R1. From R1 using R2 I am changing. Second using R1 R3 I am changing. So that is why this will be alpha 21, alpha 31, alpha 32. Sorry, 32. What are these alpha 1, alpha 32? This is nothing but this 0, 0, 0, right? This is alpha 21, alpha 31, alpha 32. This is your L. So the order is important. So this is the order you have to follow in the Gauss elimination again for LU factorization. So here you will get, what is this? Minus 6, 3 and 7 by 4. Minus 6 or 6. This is very lengthy. I will be very quick with this.
Okay. Shortcut.
No, I will tell you. Because you have to repeat it thrice to get out to the full factorization. I will tell you the first one. So here it's I forgot this. You have to negate. So this value is a negative of it. So this is a negative, negative, negative. 7 by 4 is, it's 7 by 4, right? So minus 7 by 4. This would be minus 7 by 4. So alpha, those value you have to do the negative of it. And put it. So this, if you multiply these two now, U, L and U, you will end up with A. This is what
Again transpose inverse.
So this is not inverse. This is just a decomposition. So you have decomposed it into two. So you have two set of two equations. When they multiply together, they give you one other set of equations. That's it. It is not inverse here. Now the inverse, using this you can calculate inverse. So that we have to see now. So you only right now you have A that is decomposed into L and U. Now they are asking you to calculate A inverse is equal to what, right? A inverse is what? Now we know the identity A into A inverse is equal to I, right? A into A inverse is equal to I. You know. Uh, let's say we have a system of equation. We have a system of equation, right? It is A into X is equal to C. Okay, this is nothing but your ax1 plus bx2 is equal to some C value. So this x1 x2 is your x, a are this ab. Okay, so you're getting right what I'm telling. These are your ab. So let's have this system of equation. Here what you have here a and then A inverse. So you have, let's say what you have is, what is your A value? 6 1 minus 1 6 2 2 minus 3 4 1. Then you have x. So instead here what is A inverse? So let's denote it by this thing. A inverse, let's say I am denoting by screens not visible, right? Yes. Let me just share my screen. Sorry for that. Okay, because of network issues. Okay, let's get back to this. So where I was, let's say you have this A inverse I, which can be denoted as this A. This is your A inverse. Okay, I am depicting as this one, and this is your I. Okay, we have to find out this A inverse value. Let's say you have this A system of equation. This is nothing but from till now what you were writing, right? Till now A augmented B you were writing, or AX is equal to B. This is nothing but this. This is AX is equal to C. That's it. Nothing else I am doing here. Just taking a different set of equations denoting C, B as C. Okay. Now, if you multiply both sides by, A can be written as L into U, right? That's what we saw here.
Yes, sir.
Yeah, and this 6. Okay, now what we'll do is multiply both sides by L inverse. Okay, so L inverse into L, it would be again I, identity matrix, so it can be as a 1. So UX would be equal to L inverse into C. There is C. Okay, now let's say L inverse into C. Let's denote L inverse into C by some dummy variable Z. Okay, so what this becomes, UX is equal to Z. This is what you get. And if you take this L inverse to this side or multiply both sides by L, it would be L into Z is equal to C. Correct? So what we will do is, if instead of this X, let's say this was X, right? And this was C. A inverse was X and this was C. Then you have a L here, you have a C here. From that you will get the value of Z. Okay. Because L is a lower triangular matrix, this will be a forward substitution. We'll see how it is. And then you will get some value of Z1, Z2, Z3, whatever, how many numbers you will have. And use it in this equation. You have U values, U and Z. Again you will calculate X. And that X is nothing but your A inverse. So you have to repeat it thrice because U would be 3 by 3, let's say. What was this X value here? This your A augmented B was AXB, right? X was X1, X2, X3, right? Similarly, you will have this X as a 3 by 1 and Z would be your 3 by 1. So this Z comes as a dummy variable. L also would be similar, 3 by 3. Z would be 3 by 1. C would be 3 by 1. So, but you are saying C is a 3 by 3 here, right? So what will we do? This will be one column at a one time. So let's say how to go about this one. We have L 6 1 minus 1 6 2 2 minus 3 4 1. Then using a U, I'm using this thing here. Sorry, I'm using this thing here. So L is where? Here 0 0 0 6 2 2 minus 3 4 1, right? It was 610 and then so this value are also 1. This is your L. This is X that you are trying to find. Okay. So in the X, sorry, Z you are trying. So this is your lower triangular. Your Z1, Z2, Z3 values would be there, and here the C would be your this thing, I. So C would become your I here. I, this one, 1 0 0. Are you getting? From here you will directly get the values. X1 would be 1, X2 would be 6x1 plus x2 is equal to 0. So what value we will have for x2 would be minus 6, right?
Okay.
And x3 is minus 3x1. This is what? Minus 7 by 4, no? Minus 7 by 4 x2 plus x1 is equal to 0. So from this x1 would be
But calculate x3, sir. x1, x2 is got, x3 you have to find.
sorry, yeah, x1, x2, x3 rather than x1, x2, x3 is actually z, which is dummy variable we are calculating, z1, z2, z3. So x1, z3. So this is what we are doing as a forward substitution. So back substitution means once you get x3, then you will get this value and then you will go for a z1. Forward means first you will get z1, then you will get z2, and from these two you will get z3. So what is a z3? Z3 would be 15 divided by 2. So now you have value for z, you have upper triangular matrix, and you can calculate x. And what the x would be? Your x would be these values, a11, a21, a231. So now I will use u into x is equal to z. So u is what we have is 1 1 minus 1 0 minus 4 8 0 0 12. sorry yaar, sorry for this. So you get this, right? So u would be your 1 1 1 1 minus 1 0 minus 4 8 0 0 12. This is your upper triangular matrix, and then this x would be nothing but the first column of your inverse, and the z would be your z1 z2 z3 values you have got. So from there, now you have to do the back substitution. Now you do the back substitution, then you will get the values of this. After doing this, you will get the value of a11 would be a12 and a13, sorry, a21 and a23, a31. So a11, if you calculate, it would be minus. So first you will calculate this thing. So this would be minus 0.625. Then a21 would be 0.25, and a11 would be 0.125. So this is the one you calculated using this only one of the column. You can compute for this column and this column. Again you have to do this and this. Again forward substitution, again back substitution. So forward substitution and back substitution. So for a second one, what will be the value of this? Can anybody tell me? What will be the C value? The L value will be similar. What will the C value? Z1, Z2, Z3 is same. So you will get a new different value of Z1, Z2, Z3. What will be the C value?
No idea.
Sir, it would be 0, 1, 0. So we use this lower triangular matrix multiplied by this Z1, Z2, Z3 and took this one I is equal to C. For second one, we are trying to find at this point, right? At this point, this column. First we found out this column. Now we're finding out this column. For this we have to use these values. Then using this you will get some values of Z1, Z2, Z3. Again these values will change to A21, A22, A23, A32. That is nothing but these values. And here you will have a new set of Z1, Z2 and Z3 found out using this thing. And then you will get the values of A12, A22, A32. Similarly, for a third time you have to do, and you will get a A13, A32, A33, and then you will have a whole A inverse matrix. So this is very much involved process. I would tell you to go back again what I have done. You got it right? Anybody? Sir? Maria?
So I had some signal problems.
Yeah. Actually, that's from my end only. Actually, because of the weather storm, we don't have a good connection today. But sorry for apologies for that. But actually, you're getting the concept here. If you don't get it, just go through this video again. What I have done, how I got these two things, Ux and Lz, and how do anything यार, नाइट जा रहा है बार बार.
Again disturbance, sir.
Yeah. What I can do about it. So sorry for this. It's because of the weather. Actually, we have got bad.
Could you postpone, sir? Otherwise, you can tomorrow, no problem, because still four slides are left.
Yeah, no. I'll just go through this once again, once at all, because then the next time again I have to go this, and then it would be very difficult for this thing. Students to come. I mean, the next thing also will get delayed, right? So I'll just complete it at one go. Let's let this thing. Just let me connect my slides. So maybe this is the last time. Next time maybe we will have a good connection. Yeah. So you guys can just go through this again. So we have to do ux and this lu. How I got lu is equal to z and ux is equal to c. What is the role of z? How I am getting from this a inverse? You just go again to this video, you will get it. I just rushed it, that is why it is looking very daunting, but it's very simple and you have to do the repeated process, you will get it. So this is done. We'll just see what is the last question. There are two questions actually. I wanted to discuss these. Sir has asked about what are the actual this thing use of this in the real problems and all. So this is one of the sample problem. It is involved from a civil engineering thing, but it is very easy. Let's see what it is done is here. A civil engineer involved in the construction requires a 4,800, 5,800 and 5,700 meter cube of sand, fine gravel and a coarse gravel respectively for a building a project. There are 3 pits for which these materials can be obtained. The composition of these pits are given below: pit 1, pit 2, pit 3. Set up a linear equation problem to find out how much material should be taken from each pit. So what it is there? There are 3 pits, pit 1, pit 2, pit 3. Okay, and we have a 3 different kinds of material, and from each material you can select some percentage they have given. Okay, so how you will set up a linear system of equation from this? Can anybody have a thought on this one?
Again, 3 equation and 3 unknowns.
Yeah, 3 equation, 3 unknowns. So what will be your unknowns? You mean x1, x2 and x3. Right?
Again, different proportional.
Yeah. So what would be that x2, x2, x3?
That is sand, fine gravel, coarse gravel.
Yeah. So x1 for which one? X1 will find, let's say,
sand percentage, fine gravel, coarse gravel.
Yeah. So for, let's say, for a sand we take a x. That would be not your x1. X1 would be your this. For each pit they are asking a linear equation to find material from each pit. From each pit your x2, x2, x3. From each pit how much percentage you have to add this thing. So it is point. So for pit 1 into x1 would be 0.52 x1 plus 0.30 this thing
x2 plus 0.18 x3.
No, 0.52 x2 would be this for sand, 0.20 x2 plus 0.25 x3 is equal to, so we know that a civil engineer involved in the construction requires a 5,000 milligrams of sand.
Sir, I have a doubt about that. Why you are not considered column wise? Why you are not considered row wise?
So what it is given here? What it is given
Sand,
here?
fine gravel, coarse gravel.
Sand. So it is involved construction requires this much amount of sand, this much amount of fine, this much amount of coarse gravel. So this is total you will require 4,800, 5,800 and 5,700. Okay. There are 3 pits: pit 1, pit 2, pit 3, from where material can be obtained. Now the percentage of sand in first material is this. Percentage of sand in second material is this. Percentage of sand in third material is this. Total you have a 3 these things, and total you will have to do the 4,800. So this pit. So how much you will take from pit 1, pit 2,
that is
pit
right, that is right, sir, because summation of row wise it is 100, 52, 30, 18. Again for second row 20, 50, 30. Again third row 25, 20, 55. That is summation should be 100.
That is 100. You have a total this thing. Total.
That is equal to 4,800. That is equal to 5,800. That is equal to 5,700.
This is
row wise.
This one. Okay, you got it right. Or you're still having a problem. So total sand is 4,800 it required. So total sand means total of this, right? Only sand. So only sand means 0.52 x1. x1 would be pit 1, 0.2 x2 and 0.25 x3. Total sand is 4,800. Now what? 5,800, right? 5,800, it is what? Fine gravel. So for fine gravel, pit 1 is your 0.30 x1 plus 0.50 x2 plus.
Actually, that pit is contains these 3 types of varieties of materials, sir. That is sand, fine gravel, coarse gravel, you know?
Yeah.
That is percentage they mentioned. That is total 4,800 meter cube. Of row wise consideration. Okay, you can go ahead for both the ways, sir. We will get different answer. Huh?
Obviously, how you will get, because this is for sand only, na? See, this is the sand. So from pit 1, pit 2, pit 3. What we are asking you, this is the system of equation. If we consider what will be the value of x1, x2 and x3 would be. So how much amount of sand you will take, how much of fine gravel you will totally take. Totally you will have this much of a sand percentage you have in this much of a fine gravel percentage you have with this, coarse gravel percentage you have with this. Once you take this much amount, how much amount of x1, x2 or x3 totally you have taken. That's it. From pit 1, pit 2, pit 3. Total pit, how much quantity of x1. So 52% of sand is in x1. So how much quantity of x1 is taken, x2 is taken, x3 is taken.
Okay, sir, getting signal.
Yeah. Actually, only sand it is said, right? For sand, from all the pits, how much you will take from each pit, how much percentage you will take. So it will be a product of this, right? x1, x2, x3. If you add these three, it will be about pit 1. So which one you will equate it to? Let's say you said
Sir, my
0.52
doubt is he's preparing concrete by using those material, sand, fine gravel or coarse gravel.
what it is he's doing, they have not told us. He has just told us that this much is required and there are these pits. I am taking it from that. So
Means
from
they have existing this much of capacity in each pit.
yeah, in each pit.
Then suppose he want to go for 4,800 meter cube of something construction work. How much he is taking from each
No,
pit?
not construction work. What he has said, 4,000 meter cube of sand I need. Sand only. There are respectively it is written, right? So 4,800 for a sand only. If I want to take a 4,800 meter cube of a sand and have a pit 1, pit 2, pit 3, in each pit there is 52% sand left, 20% sand left, and 25% sand left. Pit means it's a
Storage area.
It's a storage area. There is there is a high storage area. There is some 52% sand is there, 20%, 50%, 25%. In pit 1 there is a 52%. There is some different pit. There is some 20%, and there is a different pit. There is some 25%. Now, how much I have to take? So from this one, x1, x2, x3, from totally it would be 4,800. Total we have multiplied 52.2, 0.25. That's what we are doing. At the end, you will get the how much material each one has taken. From this one, how much sand has gone, how much total x1 has gone, how much total x2 has gone, how much total x3 has gone. That you will get.
Okay.
0.18 x1 plus 0.3 x2 plus 0.55 x3 is equal to 5,700. If you solve this, now this is your linear equation, right? Simultaneous linear equations. You can go into X, A augmented B and solve this using Gauss elimination, Gauss-Jordan, anything. And this is also one of this thing. So this is nothing but there are some processes. So this is a one. The figure provided illustrates a process plant. So consisting of 5 reactors connected by pipes. We are given a volumetric flow rates of interconnecting pipes. Additionally, concentration of each fluid connecting are known. So there are these 5 reactors, 1, 2, 3, 4, 5. Okay, they are connected by pipes. There is a flow rate coming in and flow rate going out. So whatever the flow rate coming in must be equal to whatever flow rate going out. Correct? Hello? So whatever the flow rate, so we have a pipes here connected to the reactors here, so pipes are connected to it. So whatever, for each one there are some flow rate coming in and flow rate going out. We have a volumetric flow rate with us and concentration with us. So we can write down the mass flow rate is equal to Q into C for each thing. For M1, M2, for everything we can write, right? And from that, so I'll just demonstrate you for a reactor 1. So for reactor 1, so mass flow rate should be constant in and out. So Q01 into C01, this is coming in, this is also coming in. So plus Q31 into C3 should be equal to whatever going out, that is Q15 into C5 plus Q12 into C2. You got this? So you have this value, this is would be 5 into 10, 5 into 10, so it would be 50 plus Q31, what is Q31? 1 into C3, that would be C3 only.
If they are not given, C3 you have to consider only.
C3 is not given. Only C03 and C01 is given. Is written. The concentration of fluid entering the reactors are given.
Divided by 2,
not good. That's what we have to find. So establish a system of equation to determine the concentration of fluid in each reactor. So C1, C3, Q15 is what? Q15 is 3 into C5, and Q12, and his last one is Q12 into 3. So Q12 you know 3 into C2. So if you rearrange it nicely, 3C2 plus 3C5 minus C3 is equal to 50.
Yeah, number of unknowns, number of equations.
This is a equation number 1. For equation reactor 2, again you will get one equation.
Total 5 reactor is the 5 equation, 5
equation you will get 5 equation, 5 unknowns, you will get the solution. So
okay.
maybe
equations are more and unknowns are less, you can easy to do it as well. No problem.
No problem. Then
but unknowing should be equal to number of equations.
Yeah. Then only.
But unknowing is less than number of equation, no problem.
No problem. That's extra information you have.
Okay, right. Thank you.
Yeah.
Okay, sir. Thank you. We'll do it.
Yeah. So you can get down just system of equation. Maybe we can use this equation to solve from in the next class using modified this thing. That's the week 3 solutions.
Right, sir. Thank you.
Maria, got it right? Any doubt?
Yes, sir, I got it, sir.
Got it, right? So maybe what I would suggest you, I rushed through this LU factorization. Maybe you can go through it again. If you have any doubt, then you can talk. You can mail me. This thing. You can this thing. At the start, I told you, right? You can put it on this discussion forum. I will address it on the next class. So,
okay, sir.
So let's wind this session up.
Yes,
thanks for listening. Maybe I'll have a good connection next time, and we'll have a better this.
Thank you, sir. Thank you. Right, sir.
Yeah. Thank you all.